Hello and welcome. My name is Rocha Juan Jesus, and this is my presentation based on the paper Laser Coloration of Metals in Virtual Art and Design. I hope you enjoyed it. As introduction, adherence art is a chronicle of areas which keep thoughts, hopes, and values to be conserved for descendants. And one of the most popular materials for art is metal due its durability, toughness, and flexibility. In the case of virtual arts, it is essential to control the quality and calorimetric characteristics of the obtained surface. That's why the connection between processing temperature and resulting colors needs to be well understood. In this case, laser coloration of metal surfaces is a method in which the needs of virtual arts could be well gained, and it provides a broad palette of colors and the ability to control the results with a very high accuracy to afford almost unlimited potential for creative work. The experimental results of this paper is separated in three methods. First, we have the metal coloration by laser oxidation. This method is used in order to obtain the desired color, actually, and by complex oxide films, which are produced by laser, and they must keep a certain thickness to control the colors. This can be achieved. The thickness can be achieved by the control of exposure temperature during the process. In this image, uh, I show the temperature range where colors are formed on titanium and the lab color coordinates of the sample. According to the taking criteria, this overall range can be divided into 9 different colors. Oxide film's thickness increases with the rise of temperature, and it leads to the shift to the reflection minimum to infrared range of the spectrum. In the case of laser nanoparticle production, which is in the middle of this slide, when the laser interacts with the metal surface, temperature overtakes the evaporation threshold, generating a metallic vapor. Due to convection, in short time, temperature rapidly decreases and the vapor condensation leads to spherical nanoparticles formation. Due to the surface plasmon resonance of produced nanoparticles, a selective absorption of white light occurs, and the reflected wavelengths results in a desired color formation. In this case, the visible color depends on the size, shape, and the distribution of the produced nanoparticles. At last, the technology of laser structuring of metals allows creating rainbow colors images by forming periodic surfaces structures on metals. The formation of the periodical structure is possible by single beam laser action. Irregularities of the surface induce the dissipation of light energy for each sequence of laser pulses. Also, it was experimentally found that laser-induced periodic surface structures formations that occur with a certain range of temperatures and is limited by the melting point of the material. As you can see on the screen, on the right side of the screen, we have an example of these surface structures that encase the rainbow color images. Well, as conclusions, it was introduced through different methods that allow coloring different metals and apply various vibrant pictures and patterns with a very high resolution and productivity in the area of art design. It was found that wear resistance is an important design property that depends on the laser coloration method. It was observed that the stability of the colors obtained depends on this property. Coloration by laser oxidation and laser structuring methods allows implementing rather stable color images which do not require special protection. And finally, it was well demonstrated that lasers could be used not only as as useful industrial tools, but also as a new exciting mean for art and visual design. Thank you very much for your attention.